In this first video, I'm going to show you exactly what a sampling distribution is using a really small population to start with to make it simpler to kind of understand. So suppose that you wanted to know the mean birth weight of all of my children, the Wilkinson children. We will take a sample size of n equals 2. What would the sampling distribution for x bar look like in this case? So to start off with, here's the population. And these are all the birth weights in ounces for all the members of the population. So our population size is only seven kids. So here's a list of all the children and their birth weights. The mean of all the individuals in this population is 84.9. So that's my population mean. If we want to come up with the sampling distribution, what we're going to do is we're going to take all possible samples of size 2 from this population. So, for example, the first sample I might have Riley and Kaya. The next sample I might have Riley and Cassidy. The next sample I would have Riley and Cadence. The next one Riley and Rustin. The next one Riley and Kendall. Riley and Ryder. Then I would have Kaya and Cassidy, Kaya and Cadence, and so on until I had all possible two-person samples from this population. Alright, so I've taken all possible two-way samples from that population, and there was 21 different possible ways to take a sample of 2 kids from that population. And our population size was only 7, so you can imagine when we kind of expand this to a much larger population that the numbers become very, very large, very, very fast. So here's all the possible samples of size 2 that we could get from that population. The next thing that I do is I'm going to calculate the sample mean, or x bar, from each of those samples. So these then are all the possible sample means that I could get if I was taking a sample of size 2 from that population. And it's interesting to note that if I take the mean of all the possible sample means, so the mean of all the x bars, or you could call it x bar bar, it turns out that that value is 84.9, which you'll recall is the exact same value as the mean of the entire population, just taking the individuals in the population. So here's what the sampling distribution looks like for all those sample means. It's basically just a histogram of all those possible sample means that you could get taking a sample of size 2 from that population of the original 7 children. So if you recall, the actual mean of the population was 84.9. So that was really close to 85, kind of right in here where I'm pointing. And kind of our goal when we take a sample in real life, we're not actually going to know what mu is, the mean of the population. The goal of our sample is to take a sample to try to guess what mu is going to be. So you're hoping that your sample mean is going to be really close to mu, the value from the population. So sampling distributions can help us kind of figure out what the probability of being close to mu is when we take a sample. So we can start asking probability questions like, what's the probability that I take a sample mean or take a sample and that my sample mean is greater than 120? So greater than 120 would basically be this part of our histogram over here. Now, because I know that my histogram was made up of 21 observations, I can just use that information to figure out the probability. So there was one value that was over 120 out of 21 total. So if I took 1 divided by 21, that would give me the probability of taking a sample and getting a sample mean over 120. So it's something like 4 point something percent. I could also say, okay, what's the probability that I take a sample and I get a sample mean that is 75 or less? So 75 is right in here. The number of sample means that were less than 75 is 3 plus 6, so 9. So the probability of getting a sample mean that was less than 75 would be 9 divided by 21, which is 40-ish, 40-something percent. So you can see how we use sampling distributions to find probabilities about sample means. So in this case, we knew that there was only 21 possible means, so that made it pretty easy. We could just use our denominator as 21, But imagine this with a much, much larger population, and we're not going to be able to do these probability calculations just by dividing by the total number anymore. Instead, we're going to rely on finding area underneath the curve to find those probabilities. So stay tuned for part 2 of this video, where I'm going to kind of broaden this to a much larger population, and we can start looking at how sampling distributions behave.